All right. I think I did all my duties there. Anyway, gosh, it's so good to see all of you. Thanks for joining us today. You're in the right place if you came for advanced topics for computer science, room 6. So I'm Cindy Chang. I know a lot of you. I'm sharing now, so I don't even know what my bio is, so I won't even read that to you. But I am just really excited to be here. I currently work for the Nevada Department of Education. I am serving at the moment as the interim director for career and technical education. And then I also oversee our IMT program, so computer science, cybersecurity, web, digital game, et cetera, et cetera. I also am a adjunct professor at Touro University in Nevada, so I get to work with teachers again. So that keeps my teaching passion lit for sure, because I work with some of the most amazing people that come into my courses. So I really appreciate that. And I used to work in Clark County School District for about 11 so years, taught computer science. Prior to that, I worked in industry, and computer science is my background and passion. And I am really fortunate to be able to be presenting today with Mark Newburn. So Mark, go ahead and introduce yourself.
Hi, I'm Mark Newburn. I'm from industry. I spent the last 10 years on State Board of Education. I led the state's efforts to make computer science a core academic subject. Professionally, I'm a computer scientist, about 40 years experience. Last 12 years, I've been the chair of the UNLV Department of Computer Science Industry Advisory Board. I'm a product of Clark County School District, took my first programming class in 1976 at Rancho High School. The last fall, I was one of the organizers and presenters at the first international conference on quantum science and engineering education for K-16. So I'm a notorious computer science advocate.
That's fantastic. I don't think you'll find a bigger nerd in the state with computer science. But I'll tell you, we wouldn't be where we are with what we have if it wasn't for the work that Mark and others that have gone before us have put this into play. Truly, I mean, the laws, the standards, the frameworks, everything. We are really appreciative of Mark and Joyce Woodhouse and many, many others for what they've done. So these are our session topics that we're going to go through today. We are going to talk about 4 or 5, I can't remember, topics that we hope that you might consider for the advanced studies course. And we'll get into that in a minute. We're going to talk about what they are, why are they even relevant, who are the organizations involved in these topics, and how do they relate to computer science? So what's out there as far as frameworks, standards, resources to help you in the classroom. And then we'll just kind of have a little discussion at the end as we go about maybe what are some other topics that you folks have in mind that you would consider. And this is really going to be like a free-flowing, we're all sitting around, I don't want to say a scrum, reaching out to Tina's last presentation, but we're all in the room. We're just having a conversation. So you're not being talked at. So please, jump in if you're excited about something or you had an experience or whatever. This is truly going to be a discussion amongst all of us. So why we decided to do this is, of course, those of you who are at the high school level know that we have new changes that have happened in our CTE pathways. So before, you had to have 3 years of a course sequence in order to be a completer as a student. We have since changed that to now it only needs to be a 2-year pathway, which is in alignment with the US Department of Ed. And so with that, it's opened up opportunities now for our students in various ways. And you can see on this chart here that after level 1, level 2, you have this smorgasbord, a buffet, if you will, of choices that they can take after that. So complementary courses that go along with the program, or dual credit opportunities with our higher ed institutions, course in industry recognized credentials, work-based learning opportunities. Maybe they want to take a second program of study. So they start with computer science for 2 years, they go into cybersecurity for 2 years. But we're going to talk about this advanced studies course, which can be taken multiple times. So maybe they took level 1 their freshman year, 2 their sophomore, advanced studies their junior. They can also repeat advanced studies for their senior year with different topics that you want to teach them. So this is just a way for us to kind of talk about what's out there, what's coming, what's industry looking for, and to give you some resources and ideas in that manner. And then Mark.
So a little bit about why we're doing this. So as we went from 3 credits to 2 credits, it created an opportunity for more teachers to teach the 3rd class, the advanced studies. Part of it is there's some national initiatives to add some advanced computer science topics into K-12. Part of federal national bills, national coalitions. And so it's been a subject with state computer science directors. This was a topic for our Computer Science Alliance, the Expanding Computing Education Pathways Alliance. It's like, how are states dealing with these up and coming topics? And in Nevada, the easiest way to deal with it is to add it into the advanced studies course. It doesn't require change any laws or any standards, and it would allow teachers who are interested in these to come in and start playing with these topics. We picked some topics that made economic sense that we could justify being CTE. We do some links to give some teachers pointers to resources. This isn't professional development on any of these individually. They're more just these are the groups that are doing it, and here's some links if you're interested in exploring it. You know, later on, if we start to coalesce around some of the subjects, maybe in future summits there'll be PD, but these are just links, and then discussions on what are some of the other topics that might be of interest.
All right, so let's get started here. So cloud computing, I'm sure many of you have heard about this. It's everywhere, right? I put the quote in here, clouds are the sky's imagination. Well, that's truly where things are happening, and true imagination with our students should also be taking place there as well. Whoops, I didn't want to click that one. Hold on. Technical difficulties. 1 second. And screen is all weird. Here we go. Let's see if we can get this back here. There we go. Okay, try this again. Okay, so anyway, so what is it? So if you don't know, cloud computing really is helpful for our small to mid-size industries because it allows them to have, think of leasing some space, infrastructures, applications, such on the internet, without having to install and maintain and have these servers and everything within their industry, their company themselves. So they're basically hosting on these remote data centers that are managed by cloud service providers. And there's examples on there. There's 4 of them. So we've got the physical and virtual servers. You've probably seen the IaaS, infrastructure as a service. So this gives you server infrastructures like servers, operating systems, virtual machines, network storage on a rental basis. So think Amazon Web Services. Then you've got like platform as a service. So this service is used in developing, testing, maintaining software. So that's what is another one that's offered. And then the other one here, we've got software as a service. And so you see some of those things up there, the service that makes users connect to the applications through the internet on a subscription basis. And so they don't have to, purchase all of these, they just subscribe and use those. So Google applications would be something that we're familiar with in education. So, well, why is it relevant? So if you look at the future trends for cloud computing, these are the top 5 that come out. So the big thing about cloud technology is that companies can use it to scale and adapt very quickly, and it reduces their costs. And so you can see that this has become a growing market, and industries looking for this and looking for our students that know how to enhance data storage capacities. How do they deal with security? Do they understand AI and machine learning, which is really huge, and Mark is going to get into that in a little bit. But just the whole Internet of Things, being more and more reliant on devices means more need for data storage, hence the cloud infrastructure. So you can see the size of the market that's going to be growing from $543 billion in 21. They're projecting that to be $864 billion by 2025. So plenty of room for our students to have access in this growing trend and market. And so here are some of the organizations involved in cloud computing. I mentioned Amazon Web Services just a minute ago. They currently have a partnership with the Nevada Department of Education and NSHEETS, or Nevada State Higher Education partners. So what happens, I think, like I'll use CSN for an example. They have a cloud computing foundations pathway, if you will, at the college, and they're working with students in Clark County School District to get the fundamentals and get some certification, and they can go flow right into that pathway and have dual enrollment opportunities. So that's a way for our students to learn that, and that can be done in the advanced studies course. So Microsoft Azure, IBM. Did Frankie join yet? Frankie, are you on with us? I can't see anybody, so.
Yes.
Here's Frankie. So yeah, Frankie, you're doing some amazing things in Washoe with the IBM virtual, right? Because I know.
Yeah, we got on with Quantum, the Qiskit, we got on there, I think 3 years ago. Each year we reserve a 8-bit quantum machine, or they write their programs in Python and like Fibonacci and what have you. We compare the performance of the 8-bit quantum versus, their workstations in the lab. It's pretty it's really interesting to them. And then my second year kids, they've actually built an 8-server hybrid cloud using ESXi, and we use it we're building our own cyber range. So yeah, I have the kids involved in a lot of really cool projects.
That's awesome. Thank you for sharing that. It's funny because you just sent an email the other day and we're chatting about it, and I'm like, this is exactly what we're talking about, exposing the students to these real world opportunities. so that even the fact that they understand that vocabulary alone and that this is available for them. So it's real, it's happening in the classrooms right now. But again, when I mentioned AWS, so these are the two in high school. They have the Intro to Cloud, so semesters 1 and 2. It's about 160 hours. Then they can move into the college courses with Academy Cloud Foundations, and both of these help them pass the AWS Cloud Practitioner Certification Exam. And the deal with AWS is that they also help cover the exam costs for the students. So, and the nice part, it's aligned to our K-12 CS framework as well. And so there's some resources on the side, the right-hand side, and just a little bit down at the bottom of what they cover in these cloud computing courses and standards. And you can see it crosses over a lot with our CS, with our cybersecurity, with big data and blockchain we'll talk about in a minute. And so it's a perfect place in advanced studies because they've learned a lot of these foundational skills already. Okay, so the next topic that is a big deal right now, of course, is blockchain. Put the quote on there that most companies don't have the luxury of focusing exclusively on innovation. They have to innovate while stamping out zillions of widgets or processing billions of transactions. So as these transactions have become more and more important, security and fidelity of the information has become even more important too. So what is blockchain? It's a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. So think of the old days when you had the accountants with the ledgers and they had to write everything. And it was very easy for somebody to maybe scratch out those numbers just a little bit, do a little funny stuff with that ledger. So think of it now as a digital ledger of transactions. It's duplicated and distributed across an entire network of computer systems on the blockchain. You can see 4 types there. And it's kind of a checks and balances, if you will, for that. So they have public blockchains where, like in education, you may be using with the free resources that are out there, private blockchains, hybrid, and then a consortium is a group of folks that are using the blockchain. And here's some reasons why it's relevant. These are some industries that are using them right now. We probably heard of Bitcoin more than anything else, but it's even more than just that. So you've got, of course, the payment processing, money transfers, but supply chains. They use blockchain to pinpoint inefficiencies with their supply chains and find out where their stuff is in real time. Digital IDs helps people control their digital identities. I'll jump right down to education. So education is exploring how to use blockchain to secure student information and data, but yet make it accessible to those that need to have access. So not just the student, but in other ways as we collect data. Think about how we have the data at K-12. We may have data after if they go into a higher ed institution in the state, but then what happens? Do we know if they've gone on into industry in their current pathway? We don't know because our systems don't really talk that way. So a lot is happening in the sphere with education. Blockchains is a company and they are actually located, they have 2 locations. One's in Germany and one's in Sparks, Nevada. And so I believe they work with our Washoe County School District with some courses and standards and such that they've written. And then the city of Reno actually uses blockapps.net for keeping track of when updates and renovations have done to their historical buildings. They have that on blockchain to make sure that, folks can have transparency and be able to access information and check on the development So I thought that was kind of a homegrown, a real world application. And then you can see listed there on the slide some of the popular platforms. Ethereum is probably one of the most popular right now. And they use a, let me go to the next slide here. They use programming language, gosh, what was it? Solidity, I think it's
Solidity,
called.
yep.
It's a new one, Solidity. And so, yeah, write that one down. That's something you definitely want to look into for the kids. But yeah, so I mean, they use C++ as well. So here is some links here. The W3C has actually, at W3C is the ones behind all of the protocols and the standards for web development. They actually have a blockchain community group. And so they're working on a web ledger protocol. So you can click there and we'll give you these slides in just a minute. And then also the US DOE has written a white paper from their ed technology division on introducing blockchains for educators. And so, I mean, it's once it reaches the DOE, that's like real stuff. They're really looking into this. So that's exciting to see that happen. And then, excuse me. So then here on this slide, we've got some additional resources. There's a video about Blockchain Learning Group has education programs for high school, and they kind of talk about that. This is a hash generator that if you want your students to kind of practice with that, and then some other links for courses and curriculum that would be available to you. And AI and machine learning, Mark.
Thank you. So this is a big up and coming topic. Cindy's got a great quote in here about AI not being artificial. It's just sort of the embodiment of human intelligence. Next slide. So some definitions. AI is a branch of computer science, basically around allowing computers to do things that when humans do them, they're considered intelligent. And this is a moving target. Over time, more and more things that we consider intelligent are being done by machines. And then probably the biggest branch or the biggest effective branch in AI is machine learning, which is basically algorithms that allow machines to learn over time and become better at what they're attempting to do. Next slide. Why do we think it's relevant? There's a major national initiative around AI. There was a major bill, the federal government level, National AI Initiative Act of 2020, that wants to push AI into K-12 to produce an AI-ready workforce. For us, we stumbled on this document from the Las Vegas Global Economic Alliance Workplace Blueprint, which is looking at jobs that are in demand. And they reference some materials from the World Economic Forum that list AI and machine learning specialists as the second most specialty that has increased in demand. So that gave us a little bit of a green light that this is something that that's of economic interest. And of course, December, they opened up OpenAI's ChatGPT. And so now I can't go anywhere without people asking me questions about ChatGPT. So next slide. So who's trying to do this to us? There's a joint initiative between the American Association for Artificial Intelligence and the Computer Science Teachers Association, known as AI for K-12. And a lot of these are the computer science for all people. These are people who used to advocate for computer science and now are advocating to add artificial intelligence. They've been developing national guidelines for K-12. They've been putting together resources for instruction, and they've been pulling together a community of practitioners and developers. Code.org has been doing some recent work on AI. I think they have a middle school curriculum around machine learning, and then the CS for All. They're also promoting K-12 artificial intelligence. Next slide. So frameworks and standards, like the first thing that the teachers ask for, what are the standards and what is the curriculum? So AI for K-12 has developed a nice set of guidelines around what they call the 5 big ideas in AI. And they have these broken down into grade bands. So you can look at, different grades and go, okay, what should people learn? Their justification is kids are now talking to Alexa. There are toys that are coming out with intelligent vision capability that can recognize kids. These are things that kids have to deal with every day. And as they come into our world, they come in with problems. A lot of them are built on machine learning that are built from large data sets that have gender and racial biases. And so we end up with AIs that also have gender and racial biases. Some of the early facial recognition algorithms didn't work on faces with dark skin. And so a lot of what they're teaching is, the ethics and implications. These are things that the kids are basically have to deal with now. A couple states for their current technical programs have already put together frameworks and standards for their courses. Georgia and Florida, I give links for both of those, basically have CTE sequences in AI and machine learning. Is there a link to the slides?
Yeah, I was going to give that after I was
Okay.
sharing. Sorry.
So in terms of curriculum, the best place that I go to is AI for K-12. They have a huge list of resources that includes some course modules for AI and machine learning and some links to some full courses. Code.org has, they've got their AI link and middle school curriculum. There's another project that I've been starting to watch called AI for GA. It's a Georgia middle school curriculum. So people are developing standards and curriculum in K-12. So other states are looking at this. We've had discussion with other states around what they're doing with this, because everybody wants to know what everybody else is doing. So next slide.
Okay, yeah, and so on the topic of Chat GPT, because that's really a big topic with educators right now. I don't know how many of you have had the opportunity to actually play around in that. Has anybody? Have you done that with your students? Go ahead and unmute, Roger.
I love it. It's absolutely amazing. And I think it's like a lot of people are really, really scared about it. But like if you teach them to actually use it the right way, it is now a personal expert who can actually guide and direct them. They need the right kinds of prompts to be able to ask the right kinds of questions to help them get to, and again, all the data that comes out is not necessarily exactly what they're looking for, right? So and it might not be accurate. And so they've got to be able to think through different things. Oh, I have these different ideas. Okay, great. Help me clarify this. Help me dig deeper. And then like, if they don't understand something, it'll continue to explain until they get to a stage where, or they can say, do my homework, and it hurts them, right? So it's up to us as educators to actually guide them, to teach them to use it the right way, rather than just leave them to themselves where they're going to hurt themselves.
Perfect. Exactly what a lot of these blogs were saying from education. Because the first instinct for a lot of folks was, we gotta stop this. We have got to ban this. We can't use it at our school. Higher ed was freaking out in some places. And then there are some professors saying, no, wait, just like you, Roger, that like, this is an opportunity. You know, it's similar when the calculator came out. They're like, no one's going to know how to do math anymore, right? But no, they actually have to use the tool. So Roger's got the right idea. How do we use this tool effectively? And what he said is what some of those early adopter professors and educators are saying, that, you know, students are going to use this. It's out there. They're already talking about it. They're already using it. My future son-in-law, he's in real estate, and you can use it to create the listing for your property that you're going to show, and ask it, you know, what is the approximate amount that it's going to cost this client with this these factors. And so it's there. It's not always accurate, but like Roger said, with everything that we have, we use that as a teaching moment. But also, having said that, we need to actually rethink how we teach and how we assess. So if we're going to send them home to do an essay, they may actually use ChatGPT to do it. And so we got to think in different ways.
So I will add that ChatGPT is also very good at writing code. So if you give someone an assignment to, you know, do this in Python, you can drop that into ChatGPT and it will write the Python code. So just to be aware.
Yes, yes, very much so. So how you view that and work with that is what a lot of folks are saying is what Roger said. Now you have them use the tool and then go back and say, okay, is this accurate? How does this actually work in the real world? Do you need to maybe reframe how you put in that request? It's quite similar to when Google first started, and our search keywords were not always the best to get the information we wanted. And so it had to be refined. So that's a lot of what's happening here. But these resources here will give you some more ideas of how folks are using it across the nation in the education field.
So the next area that we think would be of interest for this course is data science. And Cindy's got another great quote in here. So next page. So data science is basically the combination of math and statistics and computer science and subject matter expertise. And the idea is you're trying to discover hidden insight in the data. So this is a big job field. Next slide. Why do we think this is relevant? There's some interesting work being done now at National Academies of Science, Engineering, and Medicine to look at what they're going to do with computer science. The current math sequence in high school is about 150 years old. And there's some discussion that this may actually change the math sequence. I've got a link at the next page. Where they did a workshop, because people are teaching data science, computer science. They're teaching it as a separate pathway in mathematics, and they're actually looking at maybe changing how Algebra 2 is taught. Again, the Global Economic Alliance helped us. They listed data analysts and data science as the most increased in demand job field. Also of interest, both UNLV and Nevada State College have new undergraduate programs in data science. The Nevada State College is a more pure data science. UNLV's program is a different branch through their computer science degree. Okay, who's doing this to us? Well, there's a coalition, datascienceforeveryone.org, that's looking to pull together the ability to make sure that all kids are data literate. They're attempting to move data science into K-12. Another group is ucube.org. This is Stanford. And this is a website on mathematics in general, but one of their big initiatives is around injecting data science into K-12. Here's the link on the National Academies. It links to the videos of their multi-day workshop. And it also links to a paper where they survey how this is being taught in the United States. And there's a couple different models. Like I said, some people are looking at changing Algebra 2. Some people are making it independent math class. Some people are making it a separate branch of mathematics off from Algebra 2 onto AP statistics. Some people are adding it to computer science, and some people feel that it's a trans subject and that they're looking at adding it to everything. Social science, adding it to science. So they're looking at something that now becomes part of every single subject. So frameworks, UCubed has got, they got their set of big ideas that they developed from the guidelines and assessing instruction in statistical education. So I got a link there for their big ideas. I think they have these broken out by grade bands. Virginia and Arkansas have added sequences and courses in data science. So I linked their standards of learning. Next slide. Curriculum, this data science for everyone. This first link is a really good link because it's broken up by model. It's like, okay, if you wanted to teach it as an independent math class, if you wanted to teach it as part of Algebra 2, if you wanted to teach it in computer science, it breaks, it points to course curriculum based on the model. So UCLA did a course, Introduction to Data Science. I think LA Unified School District is teaching this as an independent math class. UCubed, they've got their course, Explorations in Data Science, and Bootstrap. I think they teach it in computer science. I think New York City is doing this. And then I think San Diego Unified, their school district has got an even different approach. But these are links to actual courses. Finally, quantum computing. So people doubted me about this when I said it was coming. And now it's on the cover of Time magazine. This is this month's Time magazine about quantum computing. So next slide. So quantum computing, this is interdisciplinary between computer science and quantum mechanics. And it allows us to process information in a fundamentally new way to solve problems too complex for classical computers. And quantum computers harness the unique quantum properties of superposition, entanglement, and quantum interference found in atomic and subatomic particles. So there are certain problems that grow exponentially in complexity. So the world's fastest computer is Frontier, Oak Ridge National Lab. It's the world's first exascale computer, means it can do 10 to the 18th power computations per second. But there are problems that Frontier cannot solve in billions of years or even the lifetime of the universe. And it's believed that there will be quantum computers that will be able to solve those problems within minutes or seconds. So, and one of the items of interest is the way we currently encrypt. RSA encryption that runs the internet is one of those things. So next slide. Who's behind this? Again, there was a national federal act, the National Quantum Initiative Act of 2018, and they're attempting to pull the introduction of quantum computing into K-12 to produce a quantum ready workforce. I follow this pretty closely. There's been a lot of government funding, a lot of venture capital funding. There's a lot of money going into quantum computing. Internationally, there's a bunch of country coalitions. It's developing into somewhere between a space race and a new arms race. And I've heard that national intelligence organizations have started archiving messages of interest because they believe in 10 years they will be able to decrypt them. And it made this month's Time magazine. So next page. So the Q12education.org, this is the big organization. It's government agencies and companies and education institutes, and they're starting to pull together. Their job is to take quantum computing, which is something was a graduate level physics course, and somehow drag it into K-12. And so they know that based on what's happening in K-12 is going to determine the size and the diversity of their workforce. So they're trying to figure out how can they teach this in K-12. The White House Office of Science Innovation or Science and Technology Policy, they are really big behind this organization. And the National Science Foundation has been doing a lot of funding. The CHIPS and Science Act had a big section on quantum and funding for quantum initiatives. There's another group. It's actually an NSF funded project, Quantum for All, out of Texas, where they're starting to work with teachers over the summer to teach them how do you introduce these subjects. Part of the issue, actually, I'll talk about that next page. Frameworks and standards. There's a really good document they developed that's the key concepts for future quantum information science learners. It talks about here are the fundamental things that they think that kids need to know and be able to do. And Q12 Education has put together a couple frameworks. They put together a framework for computer science. They put together a framework for physics and a framework for chemistry. So this is a tough one because it's really interdisciplinary, and you can introduce the quantum theory concepts in physics, but you lose a lot of the flavor of the subject if there's no programming involved. And so this is the link to those frameworks. Curriculum, there's an organization called Qubit by Qubit. They offer a course called Introduction to Quantum. I think they offer it as short summer, and then I think they offer it as a full year. I think as mentioned earlier, IBM Quantum, that you can sign up and get on. They have all sorts of great instructional materials, and you can sign on and actually use one of their quantum computers. A lot of people have learned quantum computing through IBM using their Qiskit tool. Their Qiskit book is really good. So this is a great place to learn things. And then the Quantum for All initiative is doing some teacher professional development. So this one's a little, we sort of did the subjects in order of, this is here now, this is coming, and this is sort of coming after the other stuff is coming. So I guess were there questions on any of the subjects, or are there questions on suggestions for other subjects? Part of it is, like I mentioned, there are national initiatives around these. And so states are trying to figure out how they're going to fit them in.
Okay, I just shared, it was hard to be doing the slides and that at the same time, but I just shared the link to the slide deck in the chat. So,
Thank you.
yes, you bet. Go ahead and unmute and, share what are some other topics, what are some questions that you have? Look at this chat to see what we have. Let me go back.
Well, some of the things that I might want to do with my kids is to get them prepped to do the Cutler Bell Award, to have them be ready to do their programming and outline and with the goal in mind of participating in the Cutler Bell Award.
That's a great one.
Is there anything about how to teach computer science to to go into the teaching field and teach technology?
Do you mean like to become a teacher, like go into an education program to become a specific computer science teacher?
Yes.
Yeah, I know that UNLV was working towards doing that.
Excellent, excellent.
They had hired well, I know UNR had hired somebody for a moment who was working in that direction, and then funding and stuff. So I'm not sure if they were able to get him back, but I know UNLV is working on that as well, because they're trying to get a particular grant, and they reached out to ask if department would be a partner in that. So they are moving in that direction for sure. And think about this too, like when you have students in your classrooms that, not everybody wants to go be a programmer, but maybe out of the class, you have students that want to be computer science teachers. And so don't even discount the students that you have in your classrooms about becoming those teachers. I used to promote that a lot, because some don't feel like they want to go into the field. They like programming, they like computer science, and they really liked when we would do projects working with the young kids.
Definitely.
And so that brought out their teaching side of things. So
Is that an option for the AS class, that they become almost tutors or teach like a freshman level or assist with curriculum development? I don't know if that's something that the AS class could have, is where they mentor others, teach other students.
yeah, I don't know, because you're supposed to go dig deeper into the pathway studies for the pathway. And so that's crossing over the two of them. But with the needing the 2-year, I mean, maybe you have some students that want to do the computer science pathway for the 2 years and then switch to the teaching and training.
Oh, that makes sense. Okay.
And then do it that way, because there's a lot of partnerships with dual enrollment, especially for the teaching and training. So Leanne had a question. OpenAI's terms of use states users must be 18 or older to create an account to use ChatGPT. How are high schools that are using ChatGPT with students getting around this with students younger than 18? Always a great question. Students seem to get around a lot of things.
So
Cindy,
I address that just by doing it on my board with my personal account and showing them how it would work, and then telling them that the terms of service didn't allow them to have their own account, but what they did in their own time was their own time. So we went through how you could do various prompts and how changing the prompt slightly gave you better results. And we talked about that for a couple of days. So that's how I addressed it.
Thank you, Scott. Yeah, Roger's got some great ideas too about other topics: entrepreneurship in tech, app development, connections to Technology Student Association, TSA. Thank you, Tina, for putting the evaluation in the chat. We have about 2 minutes left, so please do click on that link and complete the evaluation to support the conference organizers. Title of the session: Advanced Topics for Computer Science. Let's see, Lloyd, great idea, wrapping some of these topics into cyber classes, doing the advanced studies cyber. Yeah, you can see how a lot of them do overlap, from the cloud computing to blockchain to everything.
Yeah, there's a lot of work being done on changing encryption standards to make them quantum safe or post-quantum, because it is, I mean, the algorithm to break the RSA encryption already exists. It's just waiting for the quantum computer to be built. So there's a lot of work being done there.
I love Dale's comment. AI and robots, the stuff movies are made of. If you ever have a chance, go out and look at some of the YouTube videos where they're doing interviews with AI And it's pretty much the stuff movies are made of. So fantastic. Yes, you have the slide deck. Great. Well, that is the end of our session today. Thank you so much for participating and joining in with us in the discussion. Here's our information. If you want to reach out, reach out to Mark. Gosh, he knows so much on these topics and resources, and that's how you can get a hold of me as well. So thank you so much. Enjoy the rest of the conference.
Thank you.
Take care, Bo.
Thank you.
Thanks, Tina.
We made good co-hosts.
We do, don't we? Go ahead and stop recording here.